What's up, people? Welcome back to the Dirt Bike Shed. We're going to do an Edpuzzle today. A quick video on orbiting. We're going to talk about the orbit of satellites and the International Space Station. Okay, so first, here is a formula that should be super familiar to you right now. Force of gravity is equal to G, M1, M2 over R squared. So very simply, we're going to talk about the formula first. Question number 1 on your Edpuzzles is going to be, what number is G? Okay? All right, now that we've got that, now that you know that the answer to G is 6.67 times 10 to the negative 11th, I want to ask you a question. If we are talking about the International Space Station, or if we're talking about anybody, there's a certain amount of force that is keeping it orbiting the Earth. I want you to think of something for number 2. If we're going to try to figure out the acceleration of the International Space Station, I want you to tell me what we could put in here instead of F. If we're trying to solve for the letter A, what formula can we put in here for letter F? There are 2 letters. Okay? I hope you got that one right, because the 2 letters are M-A. So we know now that from number 1, letter G is 6.67 times 10 to the negative 11th. All right? All right? And that for F, we can write MA, because that is Newton's second law. Right? That's Newton's second law. Now, we have an M here, and we have M's over here. All right? Now, if we're talking about the International Space Station, it is the body that is in orbit. So we are talking about this mass being the International Space Station. We can also consider this mass to be the International Space Station. So now I want you to rewrite this formula, eliminating whichever letters that you can. Number 3, rewrite the formula, okay? Or another way to put it is eliminate what you can. All right? Okay, so here's number 3. Number 3, we're going to get rid of 2 of these M's right here. Because if both of them are the mass of the International Space Station, then we are down to this. Now, we've done 1, 2, and 3. The International Space Station is going to be orbiting the Earth. Let me draw you a picture. All right, here's an absolutely terrible picture of the Earth. And here's the International Space Station. Now, it's orbiting the Earth. All right? And we're going to have to calculate its acceleration. Now, this acceleration is in a circle. So for number 4, I want you to tell me 2 letters, or what part of a formula. Let's get rid of this letter A right here. And I want you to tell me 2 letters we could put here instead of the letter A. It comes from a formula. You're right. We could calculate, we could change the letter A to v squared over r, couldn't we? right. We can change a to v squared over r. So now we can go beyond calculating the acceleration. We can calculate the actual velocity of the space station while it's in orbit. Now, the International Space Station is at a height of 400,000 meters above the Earth. It's 400 kilometers above you when it goes by. And we know that the radius of the Earth is 6.37 times 10 to the 6th meters. So what I want you to do is add both of these numbers and tell me the actual radius of orbit for the satellite. So our next problem, number 5, what is the total radius if you add these two numbers, 400,000 plus 6.37 times 10 to the 6th? Well, the answer is 6.77 times 10 to the 6th meters. Okay? That is the radius of orbit for the International Space Station. So we're going to put that number here for the radius. 6.77 times 10 to the 6th. 6.77 times 10 to the 6th. And we need to insert one more number if we're going to solve for V. And that number is the mass of the planet Earth. Okay? You have it on your chart, but I'm going to go ahead and give it to you. The mass of the planet Earth is 5.98 times 10 to the 24th kilograms. These are in meters. This is in meters. All right. Ladies and gentlemen, your last question for today, number 6, is can you solve for the letter V? Can you solve for the velocity of the International Space Station as it circles the Earth at an altitude of 400,000 meters? Here we go. Number 6, solve for V. All right, the simplest way to do that, we're going to do some Algebra 1. We're going to take this number right here. We're going to put it on the top, right? And then that leaves us V squared. To get rid of V squared, we've got to get the square root. So we end up with this formula right here is what you should have worked. And the answer is, these calculations give you 7,676 meters per second, which is just a little bit off of reality. And we're off just a touch because we're rounding off for some of our numbers to keep it nice and simple. But there you go. There's more to come.